Hi guys, in this presentation I'm going to show you what the central limit theorem is and where you can apply the central limit theorem. In the central limit theorem you just need the concept of population and the concept of sample. All of you I'm sure know what the population is. Population is a larger data set from which you are going to take your sample. So this big circle, suppose this is your population, and the only thing you know is that population has a mean of 30 and the variance of 12. And now suppose you have taken a sample of size 44. That means you have 44 observations that you have taken. Only thing the central limit theorem says is that the distribution of the sample mean x bar follows a normal distribution with a mean same as the population mean and the standard deviation of sigma over square root of n. That's it. So there is one caveat to it. It does not say the exact distribution is normal. What it says that if you increase the sample size consistently, then the x bar tends to follow a normal distribution. Well, but there is a rule of thumb in there. That means if your sample size is over 35, you can assume the distribution is normal. So what does it tell you? It tells you that regardless what is the form of the population distribution, you can always figure out the form of the distribution of x bar. And from there you can convert that into z. Z is the standard normal distribution. Okay, so let's say, excuse me, let's say you have taken a sample of size 44 and you want to know, you have taken this sample from this population of mean 30 and variance 12. You want to know what is your probability that your observed value is going to be less than 29.76. So your step one is to identify the question. So this is your question. So the step two is calculate the standard deviation. Well, what is the standard deviation in this case? Standard deviation in this case you can easily calculate. You can say, okay, equal to SQRT. I'm taking the square root of the variance, that 12, right here, and then divided by n is 44, so 44. Okay, that is giving me sigma over square root of n. Remember, I have to take the square root of this also, 12, and then square root of that n. Okay, so this is the denominator. So to calculate z, what I need to do, I need to say, okay, I'm going to write it down, equal to x bar. You want x bar is 29. This better right here. 29.76 minus population mean is right here 30, okay, 30 parenthesis divided by, this is your standard deviation, that standard deviation, the x bar I have calculated before. So I say enter. This is your z value. So now I can say, well, x bar is less than 29.76. X bar 29.76 is same as z is 46.460. That's what I calculated, right? So now you can compute this by using the standard normal distribution table. I don't use the table, I calculate it directly from Excel, and I use the formula equal to NORMSDIST parenthesis. Then I can just either type this number or give the cell reference, enter. So this is my value. So the probability that the x bar is going to be less than 29.76 is this. So I can write x bar is less than or equal to 29.76 equal to 0.322914. Okay, so in summary, I want to say you can apply central limit theorem to answer 3 types of questions, basically. One type, x bar is less than some number. Another type, x bar is greater than some number. And the third type is x bar is in between those two numbers. And all of these 3 questions can be answered in a very simple way. Step number 1 is to convert x bar into z. How? I say, okay, equal to x bar is this, so the z will be x bar minus mu. How much is the mu? Mu is 30. So x bar minus 30 divided by standard deviation. I already calculated the standard deviation here, right? You can see. So I have given the cell reference equal to this. Now there is a danger of giving the cell reference when you want the fixed value, right? You don't want to do that. So I'm going to type that number. So type the denominator. I'm going to say 0.5222233, parenthesis close. So this is the z value. This is the z value. I had a parenthesis issue. Okay, so now you can see the formula easily right there. Mean divided by the standard deviation of the sample mean right here. So now I can just drag and drop. So I got both of those numbers. So to answer this question, I can say equal to NOR MS DIST of this number right here minus 0.45956. Okay, that gives you this probability. Now if you want to find out the greater than, so you have to say equal to 1 minus is the right side, right tail probability. So 1 minus NORMSDIST, that parenthesis, negative 16 point something. It seems to be a very large number. Oh, no wonder. Okay, hang on for a second. Let me double check this number. Yeah, that's the correct number. Okay, so equal to 1 minus NORMSDIST, left parenthesis, then I should write down negative 16.8316. One minus, not 1 equal to. 1 minus this. Okay, so it is almost 1. And to find out this, you just have to use equal to NORMSDIST, the large number, which is the upper tail, which is this number, minus NORMSDIST, the smaller number, which is this number. That will give you the probability that the x bar is between these two numbers. Okay? Let's review this one. So just remember these 2 steps, step 1 and step 2. Step 1, you convert x bar to z, and to convert x bar to z, you need these 2 values. And then step 2, you just compute the probabilities by using norm dist, 1 minus norm dist, or difference between those 2 norm dists. Okay? All right. Thank you. Bye.